Okay, today we're going to take a look at properties of parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. Okay, so that's the definition for the parallelogram. There's also 5 properties of parallelograms I want you guys to take a look at. The first one is that both pairs of opposite sides are parallel. Okay, it's not just one pair, but it's actually 2 pairs that are in that shape. Both pairs of opposite sides are going to be congruent as well. Okay? Both pairs of opposite angles are congruent. Your consecutive angles are supplementary, and the diagonals will bisect each other. Okay, so those are all the properties of parallelograms. This opposite sides parallel, opposite sides congruent, opposite angles congruent. In other words, anything that's across from each other within a parallelogram is going to be the same. Your consecutive angles are supplementary. The reason for that is that they're same-side interior angles. We'll take a look at that when we get to the picture. And our diagonals bisect each other as well. Okay, if you take a look here, we know our lines are parallel. So if we take a look, you're going to notice that angle D down here at the bottom and angle A up here at the top are going to be connected by a transversal, and that transversal is segment AD. Okay, well remember back when we did parallelograms, or parallel lines, that these 2 angles here and here would be examples of same-side interior angles. And that's the big angles at A and D and not the smaller pieces. As we look through these problems, for number 1, if AB is 12, remember that your opposite side is going to be the same as well. Okay, so if AB is 12, DC down here at the bottom is going to be 12. Now, the diagonals bisect each other. So if AE inside of here is 6, then EC is going to be 6 as well. Okay, so the diagonals are not going to be necessarily the same as a whole, but they're going to be split in half when they cross. Okay, here's another example. Okay, this time AE is 9. Okay, so this time we're looking at 9. If AE is 9, remember that is half the length across from A to C. So now if I want to look at this entire length, this is going to be 9 as well, and 9 plus 9 is going to give me 18. Similarly, if AD is 3 over here, BC down this side will be 3 as well. Okay, for number 3, if BD all the way across, this diagonal all the way across, is 14, and I want to find the portion from B to E up here, if the entire purple length is 14, that piece from B to E is 7. And similarly, if AB up here at the top is no longer 12, but rather it is 10, then CD at the bottom is going to be 10 also. The final part talks about angle ADC. Now, angle ADC is my big angle down here. So this big angle is 42 degrees. Okay, I want to find a measure of angle ABC up here at the top. Well, those 2 angles are across from each other. They're opposite from corner to corner. So angle ABC will be 42. Now, we also want to know what the measure of this angle is up here at the top from D to A to B. And those 2 angles, remember, from at A and D have to add up to 180 degrees because they're same-side interior angles. So we take 140 or 180 minus 42, and the measure of angle DAB is 138. Okay, now, we may have algebra that can incorporate in also. Okay, so if you look at your notes, you're going to notice that you have AB is 2x plus 1 and DC is 4x minus 19. Okay, well those 2 segments are going to be the same. Okay, so for number 5, I got to switch sides. You guys should have this in your notes anyways. Okay, in the same level. 2x plus 1 is going to equal 4x minus 19. And now we're solving a normal linear equation, so we subtract the x's from both sides. Okay, we'll bring the 19 over at the same time. So 20 equals 2x, and then our value for x is 10. Okay. Our next segment talks about BE and DE. Okay, so let's flip back. I'm going to flip back up here. With BE and DE, here's BE. DE is the entire length. So I know that BE is half the length from D to E. So it's always going to be easier to double my smaller part. So 2 times 6x plus 1 is going to equal 4x plus 31. So that gives me 12x plus 2 when I distribute, equaling 4x plus 31. I'm sorry, BE and DE. It's two are the same. Got that backwards. All right, so I don't need the 2 in front. Okay, so all we've got to do here for number 6 is instead just let 6x plus 1 equal 4x plus 31. Okay, and all that's going to do for us then is we're still going to take smaller x to our bigger x. So you subtract 4x from both sides. Also subtract the 1 back to the other side. So 2x is 30. And our value for x becomes 15. Okay. Questions on that? So the diagonals are going to bisect each other within our parallelograms. Okay, so when we get to the test, that's going to kind of be what the test is going to look like. It's going to look a little bit more like 1 through 4. You're going to have one picture that's going to go through several different types of problems. Okay, so just be aware of that that's what it's going to look like on the test. Okay, here I want to find my values for x and y. Okay, notice that y is an opposite angle to 65 degrees, so my value for y is going to be 65 right off the rip. We also know that AB and DC are going to be opposite sides, so that means that x plus 4 is 12. So subtract 4 from both sides, and our value for x is 8. Okay, our next example asks us to find FG and the measure of angle G. Okay, angle G and E are opposite angles. So the measure of angle G is going to equal the measure of angle E, which is 60. And GF and HE are opposite sides. So FG is going to equal 8. The problem to the right is going to continue to do the same kind of thing. It's going to ask us, so this time now we're going to have to work some algebra in. Again, J and L are opposite angles. So that means that 2x is 50. Multiply both sides by 2. So the value of x is 25. And then finally, these two sides over here are going to be equal because they're opposite sides. So y plus 3 is 18. We'll subtract 3 from both sides, and our value for y is 15. Okay. Questions on those? All right, the next question that we've got asks us to find the sum of the lengths of the diagonals within our parallelogram FGHJ and explain our reasoning. Okay, so what we've got to do first of all is find KH. Okay, so if this distance from F to K is 5, K to H will be 5. And similarly, if KJ is 7, KG will be 7. So my two diagonal lengths are going to be 14 and 10. And those will add together to give us 24. In our next example, each quadrilateral figures a parallelogram. What is our relationship of AB and EF? Because we have a parallelogram, I know that AB is going to be parallel to HC. And if HC to D to G is parallelogram, those two angles or sides have to be parallel, which means that AB and DG are parallel. And if AB and DG are parallel and DG and EF are parallel, we have that transitivity of parallels that we worked with a long time ago. And segment AB is parallel to EF, okay, by the transitivity of parallels property. Okay. And finally, last example. I want to find the length from J to M, okay, because KL over here is 8, JM will be 8. The next thing I want to do is find the measure of angle K. Okay, well there's my opposite angle, so the measure of angle K will be 72 degrees. I want to find a measure of angle MJK. Remember that these two angles here and here have to be supplementary, they're consecutive angles. So I'm going to take 180 minus 72, which is 108. Measure of angle MGK. Number 4, if ML down here is 14, JK up at the top will be 14 as well. And our final piece, suppose we add MK to the parallelogram. Okay, so that's our diagonal. And our point of intersection is JL is point Q. What can you conclude about JQ and LQ? we know that the length of JQ is equal to the length of LQ because the diagonals of a parallelogram bisect each other.